Hello everyone, my name is Danush. Welcome to the Children's Science Center. Here we have a science display with electric circuits. In this display, we have a cardboard box that has been decorated to look like a house, and we have electric circuits which light the lights and power the motorized fan. In order to make this display, we have a cardboard box that was used for the house. We used some tape and some extra cardboard and paper for decorations. In order to make the circuits, we used batteries, LEDs, some wire, a motorized fan, and switches. However, you can also make your own switch at home using one paper clip and 2 brass fasteners. The important thing when talking about circuits is to realize that electric current is released from the battery, which goes through the circuit and back into the battery. This electricity has something called electric charge. There are 3 important terms that you should know. First is voltage. Voltage is the difference in electric charge from one place to another. This is what allows the battery to have the electricity go out of the battery through the circuit and back into the battery. If you look at the battery, you'll see that they have different voltages. The batteries we used in this demonstration are 9-volt batteries. Next, we have current. Current is how much electricity flows through one place. So when there's less current, the LEDs will glow dimly. When there's more current, the LEDs will glow more brightly. Finally, we have resistance. Resistance is how much electricity is stopped from flowing through the circuit. Everything from the LEDs to the fan has its own resistance. Now we'll go to Neuron to talk about the series circuit.
Hi everyone, I'm Neuron, and today I'm going to show you how a series circuit works. In a series circuit, the amount of current that flows through each individual component is the same because there's only one path for the flow. This works like marbles in a tube, where the speed of the current is the same at any one point. In a series circuit, the total amount of resistance is equal to the sum of each individual resistance, and the same goes for voltage. The total amount of voltage is equal to the sum of each individual voltage drop. Now I'm going to explain the difference between a closed circuit and an open circuit. So in our model, we used a paper clip and 2 brass fasteners to model our switch. In an open circuit, the switch doesn't connect both points of the flow, so there's no way for the current to travel throughout the circuit. But when we connect the paper clip to both fasteners, now there is a metal pathway for the electricity to flow, which turns on the LED light. Now Justine will explain the parallel circuit.
Hi, I'm Justine, and I'm going to be talking about parallel circuits. Here we have our parallel circuit. In a parallel circuit, all of the positive side of the components connect to the positive side of the battery, and all of the negative sides of the components connect to the negative side of the battery, which we also have connected to a switch, which can turn on and off all of the components by opening or closing the circuit. In a parallel circuit, the voltage is equal across all of the components because there are only 2 electrically common points, which are where the battery connects to all of the other components. Even though there are multiple paths, they all connect to the same 2 points. The resistance, the total resistance, is also less than any of the individual resistances in the parallel circuit. Finally, the current is equal to the sum of all the branches in the entire circuit. Parallel circuits are usually used in strings of lights because when one light bulb goes out, not all of the other ones will because there are other paths for the electricity to travel through. Now we'll show you a clip of everything working together.